All right, so here's a review before you take the quiz on 1.3 and 1.4. So lesson 1.3 was at limits at infinity. So there's two ways it could represent itself. Here's one. And so at 2 is an asymptote. And I want you to know if you graph this and squared it, both sides. So if I graph this, at positive 2 is an asymptote. And because it's squared, both ends are going up. Both. So at a vertical asymptote, it's either going to go to infinity or negative infinity. So if you plug in a number like 1 or 3 or anything around it, that squaring makes everything positive. So both ends are going up. So this answer here is infinity. If I give you another example like this, I say, okay, limit as x approaches 1 from the right. At 1 is an asymptote. So if I graph that, and then what's happening around that? Now, the truth of the matter is the horizontal doesn't affect. It's either going to infinity or negative infinity. So how do I know from the right? So plug in a number bigger than 1, but close to 1, so like 2. So if I plug in 2, the answer is positive. If I plugged in 0, which is the other way, you'd notice the answer is negative. So one side it goes to infinity, and the other side it goes to negative infinity. So from the right, the answer is infinity. If this was a negative sign, from the left, it would be negative infinity. Now, what's another example that you could see for limits at infinity? Whenever you see a question that says as x approaches it, it's a end behavior question. So we take the power terms. And so x squared divided by 2x squared, that gives me the answer. And that could be to negative infinity or positive infinity. Let me give you another example. Here I want to know the left end behavior of this. Well, the power term over the power term, if I do that on the side, x squared over x, that's just equal to x. And if I graph y equals x, I can see the right end behavior is going to infinity, but the left end behavior is going to negative infinity. So where is the left end going here? So the answer is, it goes where the power term goes, which is negative infinity. If you get into a situation where the denominator is more powerful than the numerator, this is 0. Done. Doesn't matter. The bottom is more powerful. The end behavior is 0 on both ends. Be careful of this situation where you have the need to multiply it out. So I want to know what the end behavior is here. We have 3x squared and 2x squared. Just know we're looking for a number here. So if I look at the power term, it's really 3 squared times 2 squared. This number is actually going to be 36. So this is 9 and 4. Do you see where 36 comes from? And then the exponents, x squared and x squared, they add to x to the fourth. So x to the fourth and x to the fourth, what you end up with is 36 x to the fourth over x to the fourth, right? That's what you end up with. So when you divide it out, that's where that number comes from. So just be careful to square or the exponent to the coefficient to be able to get the right answer. All right, what was the other one? Was on 1.4. Now, 1.4 is the limit definition of a derivative. So if I give you a function, and I want to know what the derivative of that function is, then you should be able to write it as a limit as h goes to 0. Step 1 is to take out the x and put in x plus h. Then subtract the function without the h. And then the denominator is just h. We need to know that. And then we do algebra to be able to simplify it. So I need to expand x plus h squared. That's like foiling x plus h, x plus h. If I FOIL it out, you get x squared 2xh and h squared, and then subtract x squared is at the end of it. Combine like terms. So x squared, take away x squared, factor out an h. Divide h out, and then plug in 0 for h, and you have your answer. So that's finding the derivative from first principle using limits. The derivative is the slope using 1 point, right? So this is as it's approaching 1 point, what does it look like? Sometimes if I want to find the derivative at a point, so I want to find the derivative at 2 of this one, there's an alternate way to set this up. So we want the limit as x approaches 2. That's what I'm looking for. And then I write down the function, and I subtract, and then I plug in what the value is at 2. So 2 squared plus 2. I plug that in, and then the denominator is x subtract whatever that number is going to. So there's the setup. I combine like terms. Here's an indeterminate situation, so I'm going to factor the numerator. This allows me to remove the discontinuity and then plug in 2, and you get your answer. So the derivative at 2, the answer is 4 using this way. I'll give you one more to practice, just the setup. So if I want to know, if I give you something, and I want to find the derivative, could you set it up? I won't even ask you to simplify it, just the setup using limits. So what is it again? The limit as h approaches 0. What do I plug in first is x plus h and x plus h. Subtract, use parentheses. So subtract and now put in the function without any h's. And then the denominator is just h. All right, Mr. G Math, good luck on the quiz. Oh, there's my pen. Over and out.